differentiation of vectors. Let A be a vector depending on parameter u. This is vector A with parameter u. So you have A x u I, A y u j, and A z u k. So how to differentiate this vector? Okay, you can obtain the derivative of AU by differentiating each component separately. So you have to differentiate A with respect to U for first component I, and then J, and then K. Then you'll get dA du. Similarly, for n derivative of vector AU, when you differentiate it nth time, you have to differentiate it by its component I, J, K. So this is the differentiation of A with respect to parameter U. Then the magnitude of this differentiation is equal to, okay, the first component squared plus the second component squared and the third component squared, and then you have to square root all this together. Then you'll get the magnitude of d and a du n. Okay, so this is the differentiation of two vectors. So let's say you have au and bu. Okay, vector a and vector b with parameter u. Then you have this scalar c. So differentiate a with respect to u. You can take out the c. And then for the second property, a plus b, okay, vector a plus vector b. So you can differentiate it one by one. Differentiate a with respect to u and plus with differentiation of b with respect to u. So this is for dot product and this is for the cross product. So you know the differentiation is related to the speed, velocity, and also acceleration. So you know that speed describes how fast an object is moving, and then the velocity describes how fast and in what direction the object is moving, and then the acceleration is the rate at which the velocity of a moving object changes with time. So this is your velocity, dr dt, and then if you differentiate this dr dt, you will get the acceleration. And for speed, ds dt. So this is position for two space, okay, two dimension, and also for three space, three dimension. Okay, for two space, you have I and J, and for three space, you have I, J, and K. Okay, X, Y, and Z. So for position, RT XTI plus YTI. So when you want to find the velocity of this position, you have to differentiate it with respect to t. So this become dx dt I plus dy dt j, the second one here. Similarly, for the three dimension, for acceleration, if you differentiate velocity, you will get the acceleration. So this is your velocity. When you get this value, then you differentiate this, you will get the acceleration. And for speed, find dx dt and dy dt, differentiate according to its component, and then you have to square it, then you will get the speed. This is speed for two dimension, two space, and this is speed for three space. Okay, now look at example 1.3. If vector A is equal to 3u squared I minus 2u j plus 5k. Find dA du. Okay, dA du means you have to find the first derivative. Okay, differentiate this A with respect to the parameter u. So 3u squared, you will get 6u I minus 2j plus 0k. So this is the answer for dA du. Okay, next, d squared a du squared. That means you have to differentiate again. Differentiate this value. So you will get 6i. This is answer for d squared a over du squared. Okay, now let's look at this example 1.4. The position of a moving particle at time t is given by this vector x, y, and z. So, first question, obtain the velocity and acceleration of the particle. So, velocity, you have to find the first derivative, and acceleration is the second partial derivative. And question number 2, obtain the magnitude of both velocity and acceleration at t equal to 1. So this is the solution. This is the value for x, y, and z. Given from the question, this is x, y, and z. So when you write in the vector form, you will get this one. Okay. Position vector rt. This is your x, y, and z. Then the velocity means position over time. So you have to differentiate this r with respect to t. 4t plus 3, differentiate with respect to t, you will get 4. T squared plus 3t, differentiate with respect to t, you will get 2t plus 3. And differentiate t cubed plus 5t squared, you'll get 3t squared plus 10t. Okay, so this is your velocity, dr dt. And next, you have to find the acceleration. Acceleration means you have to differentiate this with respect to t. So differentiate this with respect to t, you will get 0. Differentiate this y with respect to t, you will get 2j. Okay, second component y. And the third component 3t squared plus 10t. Differentiate with respect to t, you will get 6t plus 10. Okay, so this is the value of your velocity and this is your acceleration. Okay, so you already obtained the solution for question 1. So next, magnitude of both velocity and acceleration at t equal to 1. Okay, look at this solution. At t equal to 1, the velocity of the particle is this 4i plus 5j plus 13k. So from this value, velocity, you just substitute t equal to 1. In this t, this and this t, substitute t equal to 1, then you'll get this vector. And then find the magnitude, 4 squared plus 5 squared plus 13 squared square root. Okay, simplify, then you will get 210 square root. This is your magnitude of the velocity at t equal to 1. Okay, next find the acceleration at t equal to 1. Okay, substitute t equal to 1 into this acceleration. Then you will get 2j plus 16k. And find the magnitude, 2 squared plus 16 squared square root. You get 2 times square root 65. So this is the magnitude of the acceleration. So partial derivative of vector A, if vector A depends on more than one parameter, okay, for example, you have u1, u2 until un. There are several parameters here. So the partial derivative of A with respect to u1 is given by this value. And for two parameter, u1, u2, you want to find the derivative del squared A, del u1, del u2. So you have to find one by one according to its component. Okay, let's look at example here. If vector f is equal to 3 uv squared I plus 2 squared minus v j plus u power of 3 plus v squared k, then find del f del u. Del f del u means you have to differentiate f with respect to parameter u. So just look at all the value of u and just assume v as a constant. So you get here 3v squared I. We differentiate this with respect to u. So you get 3v squared. And then differentiate this with respect to u. You get 4u. Okay, this is constant, so it will become 0. And then u power of 3 plus v squared. Differentiate this, you will get 3u squared. Okay. So similarly, when you want to differentiate f with respect to v, okay, just look at v here and assume u as a constant. Then you get 6uv, okay, minus j, you get 1 here. So it will become only negative j. And this will become 2v. Del square f del u squared. Differentiate this, you get 4j plus 6uk. Then differentiate this with respect to v, you get 6ui plus 2k. And del square f over del u del v, you get 6v I. Let's try exercise 1.1. Vector f is equal to 2u squared v I plus 3u minus v power of 3j plus u power of 3 plus 3v squared k. So now let's find del f del u. What is your del f del u? So let's differentiate this with respect to u. Del f del u will be 4u v I. Okay, so this is your del f del u. And then find del f del v. Del f del v, 2u squared I minus 3v squared j plus 6v k. Del f del v. Del square f del u squared. Okay, this means you have to differentiate this. Okay, with respect to u, 4vi plus 6uk. And then del square f del v squared, negative 6vj plus 6k. The fifth value, you have to differentiate this with respect to v, 4ui plus 0. And then del square f del v del u also 4ui. Okay, the last one, we differentiate this with respect to u. So only this component has u parameter. So no u, no u. So it will be 0, 0. So this will become 4ui. So that's how you get this 4ui. Integration of vectors. So the concept of vector integral is the same as the integral of real valued function, except that the result of vector integral is a vector. Okay, let's say you have vector A with parameter u, axui plus ayuj plus azuk. Then when you want to integrate this vector A with respect to u from A to B, you have to integrate one component one by one. Okay, one component to another one component. You have to integrate it by its component. Okay, look at this example. Okay, given vector f, 3t squared plus 4t I plus 2t minus 5j plus 4t power of 3k. Calculate the integration of f with respect to t from 1 to 3. So let's integrate. Okay, for I component, integrate 3t squared plus 4t. So you get 3t power of 3 over 3. So t power of 3. 4t will become 4t squared over 2. So it will become 2t squared. Similarly, for the second component, 2t plus 5. Integrate it, you become t squared minus 5t. And 4t power of 3, you will get t power of 4. And then after you integrate it correctly, don't forget to substitute the lower and upper interval. So in this case, your lower interval will be 1 and your upper interval will be 3. So substitute 1 and 3 and simplify. You will get 42i minus 2j plus 80k. Okay, let's try this exercise. Given f is equal to t power of 3 plus 3t I plus 2t squared j plus t minus 4k. Find the integration of f with respect to t from 0 to 1. So let's integrate this. T power of 4 over 4 plus 3t squared over 2 from 0 to 1. Then substitute 1 over 4 plus 3 over 2 minus 0 or 2 over 3 minus 0. Okay, so you will get 7 over 4, okay, the first component, and then 2 over 3, j, and minus 7 over 2. Okay, so this will be your correct answer.